Okay, so from the introduction video, I showed you a quick program at the end on how to take an input and then output that and stop the program. So those are the three mnemonics that we've learnt: the imp mnemonic for input, the out mnemonic for output, and the HLT for halt. So obviously you can't do very much with just those instructions. If we're going to write a more complex program, we need more functions available to us and more instructions available to be used. So the next one we need to know is the store instruction, and the mnemonic for the store instruction is STA, and then you can also put a variable name afterwards. This will be more clear once I actually show you an example. And it says the code is 3, and then there's 2 spaces. Now the spaces are filled in with whichever memory location you're actually storing the value into. So if I was storing a value into memory location 5, it would say 305. If I was storing it into memory location 63, it'll be 363. We don't need to worry too much about the code, but that is why there's no numbers there. And description of this is the store instruction will copy the value from the accumulator and place it in an allocated memory location referred to by the variable name given. So I could use a variable name here if I call it number, and what that does is it is going to store the value that's in the accumulator. It's going to copy it and store it in a memory location that has been allocated the name number. So when you create a variable name, a reference, you're literally labeling a memory location with the name you're writing in, so that later on it knows where to store it. And the next action then after it, as the value's been copied, it obviously moves on to the next one. And most instructions will do this, until some we'll see in a later video. We also need to know how to retrieve data from the memory. So to do this, we use the load instruction, which is LDA. And then obviously if it was stored in a memory location that you assigned a name to, if you gave it a variable name, then you can use that name there to load it from that particular location. And it will copy the value stored in that memory location, and it'll copy it into the accumulator. So I said in the last video that everything kind of goes through the accumulator as a middle step. If you're storing, it takes what's in the accumulator to the memory location. If you're loading, it takes what's in the memory location and copies it into the accumulator. And this is quite an important one. So you use the data instruction to tell the program that you need to reserve a memory location in order to store a variable, in order to store some data. And you can refer to this location by the variable name that you give it. So you might be familiar with how you define variables in other languages. Maybe in Python, you would write the name of the variable equals, and then you'd give it a value that you want to store in that variable. So this is how you define variables in a similar way in assembly language. So you're telling it that you need to keep a memory location, reserve a memory location, and label it with this variable name. Perhaps number, perhaps it's number 1 or first input. Whatever you use, you'll then be able to refer to that particular memory location using that same variable name. The 3 x's here just mean that you can give an initial value by putting a value in instead of those x's. So if I put number.5, then the variable number, that memory location that is referred to as number, will have the value 5 stored in it when you begin the program. If you don't put a number there, then it'll automatically, the default value is 0. So it'll put a 0 in that location for you. After the memory location has been reserved, the program counter will move on to the next memory location. This is a bit of an odd one. I'll show you how we use this when we're actually solving the program. So this is just a comparison of a program in Python with a program in LMC. So you've got here in Python, I'm taking an input. It says for the user to enter a number, and then I'm converting it into an integer. So whatever they put in, it'll convert it into an integer, and it stores this, it assigns this to the variable name num. So whatever the user's typed in, converts it into an integer, and it assigns it to the variable num. And then the print function just displays num to the screen. So it's taking an input, it's storing it in a variable, and then it's displaying that, whatever that variable is, on the screen. So that's how you do it in Python. Then here on this right-hand side, we've got the assembly language version. So the little man computer version. So I'm taking an input, I'm storing it in an address which is labeled num. Then I'm loading it from that address again, which is labeled num. So I'm loading whatever value is stored in the location that is labeled num. And then I'm outputting it and stopping the program. And right at the end, this is where you declare your variables. If you didn't put this line here, when you try to submit this code, the program would get to this line and say, well, I don't know what the word num is. Now, unfortunately, the actual simulator doesn't tell you this. I'll show you an example of when that's not working later on. But you need to remember to always, if you're going to use a variable name, you always need to write at the end of your program, after all the rest of the code that you need, you put any variable names followed by dat as the instruction to reserve locations for your variables. Okay. So how do we write an assembly program? So this is an example of how we'd write a program that would take in two inputs and output them in reverse order. So we have to output the second input before the first one. So we know we're going to have to store the first number at some point. We need to store it so that we can retrieve it later when we output it after we've output the second number that was taken in. So we need to take an input. And then we store that input. So we store it away for later. We can retrieve it later when we need to output it again. Then we take a second input. So we've taken an input and stored it, and we called it number 1. Then we took a second input, and we output it straight away. Because we're only taking two numbers in, we can take the second number and output it straight away. We don't need to store it in the memory. Because when we take an input, it's already in the accumulator. So remember, an input takes from the input box and puts it into the accumulator. And the output instruction takes whatever's in the accumulator and stores it in the output box. So there's no need for that to go into the memory because we're just inputting it and then outputting it straight away. And then the last step is we need to output the first number. Now, because that isn't currently in the accumulator, we need to load it from the memory where we stored it, and we stored it in a location labeled number 1. And then once we've loaded it into the accumulator, that's when we can output it again. And that program would allow you to take two inputs and output them in reverse order. So you might want to have a go at actually writing that into the program. There's actually something missing off that slide. So I want to see if you can fix it because there's code missing. You have to put it at the end here to get this to work. So try and do that. Maybe pause this video and then I'll carry on. Okay, so we're going to try and do these tasks. So the first one, we need to create a program which takes and stores two inputs from the user and outputs the first input followed by the second input. So we take and store two inputs, and then we output the first input followed by the second input. So it's important when you're using, or when you're trying to make any sort of program, that you can visualize exactly what are the steps you need to do without even thinking about the actual language and how you do it in that specific language. What are the actual steps you need to do in order to get this program to work? So first of all, we need to take in and store two inputs. So you need to take an input and store it, take an input and store it. So that's the first thing to do. It's the first bit of code to do. And then we need to output the first input followed by the second input. So it's similar to the last one, but we need to do it in the order that we've entered them in. So I'll let you guys have a go first, and then I'll do the solution. So pause the video now, and then I'll show you the solution. Okay. So the problem says to take and store 2 inputs, first of all. So I know the first thing I need to do is take an input. So I'll put in the input instruction. Then it said that I had to store both of them. So the first input, I need to store it. So STA, and because I know I'm going to have 2 numbers, I can call this first, and I'll call the second one second. Notice that when I write variable names, it's all lowercase. So we use camel case here, starting with a lowercase letter. And this just means it's more readable. It stands out that that isn't an instruction. That is a variable name. So I've taken an input and I've stored it. I need to take 2 inputs. So I need to take another input. And then I store that one as well, because the question or the task told me to store both of them. And I'm going to call this one the second. Then, after I've taken 2 inputs and stored them, I need to output the first input followed by the second input. So, whenever I need to output something, usually what I'll need to do is load it into the accumulator first, and then use the output instruction to take it to the output box. So, in order to load, I need to use the LDA mnemonic. I load the first number, which remember I stored in a memory location that I've labeled first, and I output it. And then I also have to output the second one. So I do the same thing. I load second, which takes it from the memory location on the right hand side, loads it, copies it into the accumulator, and when it's in there, if I use the output instruction, it'll output it to the output box. So out. And I'll just show you, this won't work. And for the same reason I mentioned earlier, you can see here that the code isn't all written there. So something's gone wrong. And it says down here, it's not very clear, but it says unknown address label at line 1. So because I've used the word first, but I haven't kind of told the program, I haven't defined that as a label for a memory location, it's not sure what to do. So it's got stuck there. So I need to add at the end of my program. So what is the name of the variable? It's first. I put dat. I don't need to give it a value, so I can leave, I don't have to put a value afterwards. But I also need to do this for the word second as well, because it needs to know that that is also a label for a memory location. And once I've done this, if I click submit, you can see now that there are the same amount of lines in both columns here. So all of the program is fine, it's all compiled, and it's ready to go. So if I now click run, I can speed it up, and it'll ask me for an input. So if I put in 5, now what it did is it took that and stored it. If we look here, so where is it storing the first? It's storing it in box 8. Because if you look down here, where I've declared first that is in box number 8. I've reserved box number 8 for the data which I've labeled first. Or I've labeled the box 8 as first. So when I store into first, it's storing it into box number 8. I input 5 and I stored it. And if you look at box 8 up here, you can see that 5 from the accumulator, the store instruction copied it into box 8. So what's going to happen with the next instruction? I'm taking a second input, and where is it going to store it? So second, it says STA 09 because I've declared second and it's on line 9 there. So this will actually get stored in box 9. So I put 45. That will be stored now in box 9. There's one thing I forgot actually in my code here, and it can actually cause problems if you don't do it, is I forgot to put a halt instruction at the end before I declare first and second. The reason it's important to do that is because all the instructions are stored as numeric values here. What would happen if I stored as my first number the number 901 and I didn't put the halt, is the program would carry on, it would output that number, and because I'd stored 901 as first, it'll get to the ninth box and think I need to take another input again. So if I just show you that running, I'll speed it up until we get to the second input. So if I put in 901 here, now that in box 8, 901 has been stored. So the problem with this is if I didn't put a halt before it, the program will now interpret that as another input instruction. Now, if you're very clever and you wanted to make a program that was complex that you could utilize that, but at this level, we don't really want to be mixing up our data with our instructions. So you see this time now, I press 23, it's reached this box and it's asked for another instruction again. Another input again because I put 901 in there. So it's always important to put a halt before you declare any variables. Okay, so the next program I want you to try, well, I'll ask you to try both of these now, and then pause the video and see if you match up with what I've got. Okay, so the first one, create a program which takes and stores 4 inputs from the user and always outputs the third input. So the first, I know I'm going to need 4 inputs. So I'll call that third dat, and fourth dat. Then above this, what do I need first? Takes and stores 4 inputs. So remember, whenever we're taking and storing 4 inputs, or taking and storing an input, we always need imp, followed by store, and whatever variable name we want to call it. So store first, imp, store second, imp, store third, and imp, store fourth. Now I want to output only the third one. Now it's stored in the memory, so I need to load it from the memory into the accumulator first. Load third, and then once it's in the accumulator, we can just output it. And remember to halt the program once you want it to finish. So that is the code for the question 2 here. If we quickly run it, we should see that. So I put in 5, 6, 7, 8. It outputs the third one, which was 7. Okay, and the second program then, create a program which takes in 3 inputs and outputs them in reverse order. So it's very similar to the one we showed before. I only need 3 inputs here. Well, actually, I can do it with just 2. 3 variables. I can do it with just 2. So, obviously we need to take inputs again. I need to store the first one. Input. Store second. And I can take an input. Now, because it's the third one, whatever I input is going to be in the accumulator, I don't actually need to store that into memory. It's pointless to do this. If I store third and then load third, it's pointless doing that because third was in the accumulator anyway if I was going to output it. So if I wanted to take an input and output it, which is what I want to do now, there's no point in storing it into memory, then loading it into memory and outputting it. I can just skip those 2 steps because the third number is the third input. I'll just output that straight away. Then I need to load the second one, output that, and load the first number that was input, and output that. Oh, I've got 2 outputs there. So actually, I don't ever use the third variable. So I can delete that line too. Okay, and that's the code for the third task. So I put 5, 6, 7. It gives me back 765. So those are the tasks on storing and loading. So there's a code summary of what we learned so far. Then in the next video, I'll show you how to do the tasks on addition and subtraction too.